I'm Anish. Let's explore what exactly a large language model is. Unlike traditional AI systems that follow rigid rules, LLMs learn from vast amounts of data to understand and generate human-like language. First, LLM stands for Large Language Model, an AI trained on massive text datasets to understand and generate human-like language. These models are trained to predict the next word in a sequence, which helps them learn context and grammar. They contain billions of parameters, adjustable values that determine how the model behaves and responds. This allows them to generate coherent and contextually relevant text, making interactions feel natural. Examples include ChatGPT, Claude, Gemini, and Llama, tools you may have already encountered. Now that we've seen examples of LLMs in action, let's dive into how they actually work. Understanding these mechanisms will help you appreciate the technology behind tools like ChatGPT and Claude. First, during the training phase, the model learns patterns from billions of text examples. Think of it like reading an entire library to understand language patterns, grammar, and how words relate to each other. Before processing any text, LLMs use tokenization to break text into small pieces called tokens. These tokens can be whole words, parts of words, or even punctuation marks. The attention mechanism is what makes LLMs so powerful. It allows the model to focus on relevant parts of the input when generating responses, similar to how you focus on keywords when reading a sentence. When generating text, the model predicts one token at a time, building up the response sequentially based on patterns it learned during training. Finally, fine-tuning takes a general model and trains it for specific tasks or behaviors. This is how we get specialized models for coding, medical advice, or customer service. So to summarize, LLMs learn from massive text data, break input into tokens, use attention to focus on relevant parts, predict tokens sequentially, and can be fine-tuned for specific purposes. On the next page, we'll test